everyone, welcome to Career Flight. Today we will be starting with new quant aptitude topic, that is permutation and combination. We will be learning here some basic concepts, some short tricks, some formula based questions and most recent questions that were asked. So let's begin. So what is permutation and combination? So if you look to the permutation formulas or what is permutation, permutation is defined as an arrangement of R things that can be done out of total n things. Suppose we have 10 balls. We need to draw 4 balls from 10 balls and we must have to arrange it. When it comes to arrangement, we use permutation. Permutation is nothing but arrangement of R things out of total n things, and it is denoted by NPR. We denote this by NPR, or we can also denote this as P n comma R, which is given as n factorial. N factorial is n factorial by n minus R factorial. This factorial can be also written as in this format, say n factorial. We can also write in this denote. Now next comes to the combination formula or combination. So what is combination? Combination is nothing but a selection of R things from the total n things. We must have to only select, not to arrange. So combination is only selection. It is given as NCR, or you can also write it C open bracket n comma R. It is given as n factorial by R factorial into n minus R factorial. So as per the fundamental principle of counting, if a particular thing can be done in m different ways and another thing can be done in n different ways, then either two can be done in m plus n ways and both of them can be done in m into n ways. So you must have to remember this formula. Let us see some useful relationship of permutation and combination. So here 0 factorial. Most of you might think that 0 factorial is 0, but it is wrong. 0 factorial is never 0. 0 factorial is always 1. So you must have to remember that 0 factorial is always 1 and 1 factorial is also 1. Here NC0 means n factorial by 0 factorial into n minus 0 factorial, that is n factorial, it will be 1. For n factorial you can write as n into n minus 1, because what is n factorial? N factorial is nothing n into n minus 1 into n minus 2 till 1. So what we can write here? We can write here as n into n minus 1 factorial. Let us take an example for understanding. Suppose we take n factorial n to be 8 factorial. So what will write 8 factorial? 8 factorial will write as 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So here if you write 8 as 8 and this 7, from 7 to 1, what will be? It will be 7 factorial. So this, if you write in terms of n, it will be n factorial as n into n minus 1 factorial. So next come NPR formula. We already have seen what is NPR, n factorial by n minus 1, n minus R factorial. Similarly, for this formula, n plus 1 into NPR equal to n plus 1 by P into R plus 1. So this is also an important formula. When you can take the left hand side and derive it, you will get the right hand side. Similarly, for this NCR, sorry, this will be R not P, NCR as NPR by R factorial. If it is NCR, we can also write this as NPR by R factorial. How? Let us see. So what is NCR? NCR means n factorial by R factorial into n minus R factorial. So what is given? NPR by R factorial. So what is NPR? N factorial by n minus r factorial by r factorial. So this denominator will come down, so it will be left hand side equal to right hand side. Similarly, for this formula, NCR equal to n by n into n c n minus r. We can also write NCR as n c n minus r equal to NCR. So these are some of the relationship of permutation and combination. So based on this relation, let us solve some problems. So let us proceed to the question number 1. So in the question number 1, we have, in a group of 6 boys and 4 girls, 4 children are to be selected. In how many different ways can they be selected such that at least one boy should be there? Means only at least one boy. Say we must have to select 4 children. 4 children we must have to select. So what will be the probable cases? If it is boy, this is girl. So what will be the probable cases? At least one boy must be there. Means 1, girl 3, at least one boy. 2 boy, girl 2. So 3 boy, girl 1, and 4 boy, girl 0. So these are the probable cases. So this thing can be done by either two methods. So I will let you know what we can do it. So let us proceed to the solution. Here we must have to find at least one boy. Means how many total ways it can select? Total ways. At least one boy means total ways minus no boys. Total ways minus no boys. If you subtract from total ways minus no boys, all the cases there will be at least one number of boy. If you subtract the total number of ways, and from that if you subtract no boy, that is in this case girl, we have 4 girls and 0 boys. If you subtract this case from the total case, so we will get at least one boy case. So this can be solved by from 10 children. Total children are how many? 6 boys and 4 girls. From 10 children we must have to select 4 children, that is 10C4. Only selection, not arrangement. We must have to select. So it will be C, that is combination. From here 4 boys, no boys matlab from 4 children if you select 4 girls. From 4 girls if you select all 4 girls, that is the case of no boys. So if you solve this, you will get this to be 10 factorial by 4 factorial into 10 minus 4, that is 6 factorial, minus 4 factorial by 4 factorial, 4 minus 4, it is 0 factorial. 0 factorial is 1. This what we can solve? 10 into 9 into 8 into 7 into 6 factorial by 4 into 3 into 2 into 1 into 6 factorial. This 6 factorial gone, and here this gone. 0 factorial is 1, that is minus 1. So this is 4 2s are 8 and 3 3s are 9, that is 30, 210, 200, sorry, it will be 210 minus 1, it will be 209. So 209 is our correct answer. All these things we can do by, first we can note down the cases, that is for boy, this is for girl. At least one boy must be there, that is 1, 3 girl, 2, 2, 3 boy, 1 girl, 4 boy, 0 girl. So if you take these cases, like it will be in longer way. So this we can also do by from boy, from 6 boys we will select 1, that is 6C1 into, from girls 4 girls we will select 3, 4C3, plus from boy cases 6C2 into, for girl it will be 4C2 plus 6C3 into 4C1 plus 6, 3, 4 into 4, 6, 0. If you also solve in this way, you will get the similar answer, that is 2009. So 209 is our correct answer. So what we have done here is that, so for solving this problem, we must have to select at least one boy. So what we have done here is that total ways minus no boys. So what is the total ways? Total number of ways, that is total we have 10 children, that is 6 plus 4, that is 10. And since it is selection, so it will be C, combination. From 10 children, we must have to select 4. Minus will eliminate the no boy cases, that is all 4 are girls, means from 4 girls we will select 4 girls. If you eliminate this, you will get only the at least one boy, that is from total ways, that is 4C4 minus 10C4 minus 4C4. If you solve this, 10 factorial by 4 factorial into 6 factorial minus 4 factorial by 4 factorial into 0 factorial. If you solve this, we will get the answer to be 209. So 209 is our correct answer. Or we can do in this method, that is we can find out the number of cases and we can write accordingly. So let us move to the next question. So in this question we have 10 points are selected on a plane such that no 3 of them are collinear. How many different straight lines can be formed by joining these points? So let us proceed to the solution. In the solution we have a straight line is formed only by joining 2 points. So if there are 10 number of points, 1, 2, 3, 4, 6, 7, 8, 9, 10. 10 number of points. We have to join 2 points. If we join 2, we can only get a straight line. For getting a straight line, we must have to join 2 points. So here it is also given that no 3 points are collinear. Collinear means if the points, say these are 3 points or 4 points, if the 4 points are in a line, then it will be the line drawn through it, it will be the line through collinear points, because all these points are in a line, so it is a collinear point. So it is also given that no 3 of them are collinear. So how many different straight lines can be joined from this point? So it is very easy. From 10 points we must have to select 2 points in order to make a straight line. That is, this is the total number of points. From here we will select 2 points to get the number of straight lines. From 10 points, if you select 2 points, it will be 10 factorial by 2 factorial into 10 minus 2, 10 minus 2 factorial, that is 10 into 9 into 8 factorial. We can write by 2 factorial into 10 minus 2, 8 factorial. This will cancel out. So 2 factorial means 2, 2, 5 is 10. So the number of ways is 45 ways. So 45 is our correct answer. So what we have done here is that, so we must have to find the number of lines from 10 given points, and it is given that no 3 points are collinear. Suppose these are 10 given points. For drawing a line, we must have to join 2 points, and it is given no points are collinear, means no points lie in a, no 3 points lie in a straight line. So what we have done here is that from 10 points we have selected 2 points, and since it is selection, it will be combination, that is it will be 10 factorial by 2 factorial into 10 minus 2 factorial. If you solve this, you will get the answer to be 45. So 45 is our correct answer. So let us move to the next question. Here, so in this question we have, there are 6 students to be seated around a circular table. In how many ways they can be seated if 2 particular persons are next to each other? Here it is said there are 6 students, 1, 2, 3, 4, 5, 6. In this case, 2 particular students, they will be always seated together. They will be always seated together. So in how many ways can we arrange it? because for 6 students we can arrange in 6 factorial, but here it is given that 2 students always sit together. So how will we arrange it? So let us proceed to the solution. Here, since 2 students are always together, so these 2 students will occupy, say these 2 students will occupy always this place, and only between them only, and also they can interchange between them. That is, if they interchange between them, what will be, in what factorial they will interchange between them, because they have 2 students, it will be arranged between them as 2 factorial. Suppose say Rahul and Akansha are 2 students, they will be seated together. Either Rahul will sit in this place, Akansha will sit in this place, or either Akansha will sit in this place and Rahul will sit in this place. So we have 2 possibilities, that is 2 factorial. And since they are seated in a circular table, so we have this formula. Since if someone sits in a circular table, if some students sit in a circular table, we have this formula as n-1 formula. This is an important formula, it usually comes in exam, so better remember this formula, n-1 formula. So if there are 6 students seated in the circular table, so the number of ways it will be 6 minus 1 factorial, that is 5 factorial. But in this case 2 students are always together, that is this 1 2 3 4 5 1 2 3 4 5 6, total we have 6 students and these 2 are always together. So number of possibilities is 1 2 3 4 5, total number of students is 5. So they can be arranged in 5 minus 1 factorial, that is 4 factorial, and between these 2 they can be arranged in 2 factorial. So the number of circular arrangement, it will be 2 factorial into 4 factorial, that is. So what we have done here is that since it is given two particular person always sit together, so they can be arranged in 2 factorial. Say Rahul and Akansha, first Rahul will sit in this place, then Akansha will sit in this place, and in the next case Akansha will sit here, Rahul will sit here. So we have 2 possibilities, and we know that in a circular arrangement, if there are n students, so they can be arranged in n-1 factorial. This is an important formula. So suppose if you say 6 students are arranged in a circular table, so they can be arranged in 5 factorial. Here we have 6 students, but 2 of them are always seated together, so it will be 5 students, 1 2 3 4 5. So 5 students around a circular table can be seated in 4 factorial and 2 factorial for this. So the total number of arrangement, it will be 2 into 4 into 3 into 2 into 1, 4 3 is 12, 4 is 48. So here the answer is 48. 48 is our correct answer. So let us move to the next question, that is question number 4. So in this question we have, if P of 5 to equal to P of n to find n, means what is given? NPR. What is P of NR? So P of NR you can also write as NPR, that is n factorial by n minus r factorial. So what will be for this case? It will be for P 5 2, it will be 5 P2, that is 5 factorial by 5 minus 2 factorial. So here it is given P of 5 2 equal to P of n2. So what is P5 2? It will be 5 P2, that is 5 factorial by 5 minus 2 factorial, that is you can also write this as 5 factorial by 5 minus 2, that is 3 factorial, or you can write as 5 factorial by 3 factorial is 3 into 2 into 1, that is 6. Similarly for Pn2 it will be n factorial by n minus 2 factorial, that is P n comma 2 is np2, that is n factorial by n minus 2 factorial. This n factorial you can write n into n minus 1 into n minus 2 factorial by n minus 2 factorial, that is n into n minus 1. So what will be? This will be 6. This is not 6 factorial, it will be 6, only 6. Sorry, 5 factorial by 6 equal to n into n minus 1 into n minus 2 factorial by n minus 2 factorial. This 2 will be cancelled out. So it will be left with 5 factorial by 6 equal to n into n minus 1. So what is 5 factorial? We know that 5 factorial is 120, and if you divide this by 6, we will get 20. 20 equal to n into n minus 1. N into n minus 1. So if you find the factors of 20, so n it will be 5 and n minus 1 equal to 5 minus 1, that is 4. That is 5 and 4 are the factors of 20. So here we cannot take 4 because 4 will have negative value and it will be minus 4. So the correct answer of n it will be 5. So 5 is our correct answer. So what we have done here is that it is given p of 5 2 equal to p of n2. So what is p of 5 2? That is 5p2, 5 factorial by 5 minus 3 factorial, that is 5 factorial by 6. So what is p of n2? It will be n factorial by n minus 2 factorial. If you solve this, we will get the value to be n into n minus 1. If you equate 5 factorial by 6 with n into n minus 1, we will get the value of n to be 5. So 5 is our correct answer. So let us move to the next question. In the next question we have find total number of 3 digits odd number by using the digit 2, 3, 4 and 5 when repetition of digits are not allowed. Here the digits are given 2, 3, 4 and 5, but the repetition of digits are not allowed. So the digits can be 2, 2, 2, 2 or 3, 3, 3, 3. Here it is given 3 digit odd number. Find the total number of 3 digit odd number. So it will be not 4 digit, it will be 3 digit. That is 2, 2, 2, 3, 3, 3. But 2, 2, 2, 3, 3, 3 can't be possible because repetitions is not allowed. So the number might be 1, 2, 3 or 4, 5, 6 like this. So let us proceed to the solution. Here it is given it must have to be 3 digit number and it must have to be odd number. For 3 digit number we have 3 places, okay, and the total number of digits is 2, 3, 4, 5, and it is also given that 3 digit number has to be odd. For odd number the number should be either 3 or 5. For odd number, the unit place must be either 3 or 5. So it has 2 possibilities. Here we have 2 possibilities. Can be either 3 or 5 in order to be odd. So since we have 2 possibilities, so let us see the 10 digit and 1000 digit possibilities. For 10 digit, how many we have? From 4 digit, 1 digit is gone. So we have 3 possibilities for here. For this 1000, out of 4, 2 is gone. How much we have? 2 possibilities. So the required number of ways it will be 2 into 3 into 2. That is 3 to the 6 to the 12 ways. So 12 is our correct answer. What it is given in the question is that we have to find 3 digit odd number using 2, 3, 4, 5 when repetition of digits are not allowed. So the number can't be 2, 2, 2 or 3, 3, 3 because in this case repetition is allowed. So we have 4 digit number, 4 numbers. We must have to find 3 digit odd number. For odd number it can be either 3 last digit or it can be either 5. So we have 2 possibilities. So if 1 is gone, how many numbers is left? It is left with 3 numbers. And if 2 numbers is gone, how many numbers is left? It is left with 2 numbers. So the number of possible ways it will be 2 into 3 into 2. It is 12 ways. So 12 is our correct answer. So let us move to the next question. So in this question we have, there are 5 blue flags, 4 red flags and 3 green flags in Debu's wardrobe. Okay. He has to select 4 flags from the set. in how many ways can he select these 4 flags such that there is at least one blue flag and exactly one green flag in them. So do not consider that the flags are in pairs. So let us see the possible number of cases in this question. So let us see the solution and we'll discuss the possible number of cases. So here the possible number of cases, what will be the possible number of cases? He has to select 4 flags from the set. So 4 flags we need to select. Now how many blue flags he have? He have 5 blue flags, 4 red flags and 3 green flags. Now in second part it is given he has to select 4 flags from the set. In how many ways can he select these 4 flags such that there is at least one blue flag? So blue flag must be at least one, means one blue flag, at least one. It may be 1, 2, 3, 4, 5. So at least one blue flag and exactly one green flag. So green flag always it will be 1. So it will be always 1. So how many red flags it will be there? If 2 are gone, total number of flags is 4. 2 red flags. Second case, green flags will always be 1. So here at least one blue flag. Next flag it will be 2. 2 plus 1, 3, 4. In next scenario, it may have 3 blue flags because blue flags need to be only at least 1. Red flag here it will be 0 and green flag there is always 1. So we have 3 cases. So the cases will be from this 5C1 into, from 4 red flags 2 are selected, 4C2 into, from 3 green flags exactly 1 is selected, 3C1. This is the first case. Let us move to the second case. In second case we have from 5 flags 2 are selected, 4 flags, 4 red flags 1 is selected, 4C1, and from 3 green flags 1 is selected, exactly 1. This is the second case. In third case we have 5 blue flags 3 is selected, then from 4 red flags 0 is selected, and from 3 green flags 1 is selected. So we have these 3 cases. As you can see here, 3C1 into 5C1 into 4C2, 3C1, 5C1, 4C2, 3C1, 5C2, 4C1, 3C1, 5C2, 4C1, and here 3C1 and 5C3. Here 4C0 means it is 1, 4 factorial by 4 factorial, 0 factorial you know 1, 4 factorial by 4 factorial it will be 1. So if you multiply 1 with any number you will get 1. So if you solve this you will get the value to be 240. So 240 is our correct answer. So what we have done here is that first we have taken out the possible number of cases. Since it is given 4 flags need to be selected from the set, so number of flags must be 4 flags, and it is also given at least one blue flag and exactly one green flag. So green flag always it will be 1 in all the cases. So blue flags need at least to be 1. So in first cases blue flag is 1, red flag 2, green flag 1. Second cases blue flag 2, red flag 1, green flag 1. Third cases red flag, blue flag 3, red flag it will be 0 because 3 plus 1 4, already 4, it is 0. So the number of cases, if you take the number of cases, it will be 5C1 into 4C1 in 4C2 into 3C1 plus second cases 5C2 into 4C1 into 3C1, and in third cases 5C3 into 4C0 into 3C1. So if you solve this you will get the value to be 240. So 240 is our correct answer. So this brings to the end of our today's video.
Thanks for watching our video. If you do like our video, please give a thumbs up and subscribe to our channel. And don't forget to click the bell icon to never miss our video. Thank you.